Okay, Algebra 2, we are going to start our next chapter, our last chapter for the year. We'll have 3 assignments this week, 3 assignments next week, and then the last week of school, you'll just have the study guide and the last test for this chapter. So that's what the rest of the time is going to look like for you. So this chapter is called Sequences and Series, and this lesson is Introduction to Sequences. So it starts with a lot of definitions. A sequence is a set of numbers with a particular order or pattern. Each number is called a term. And then we've got a finite sequence, which is a sequence with a limited number of terms. Example here, 1, 2, 3, 4, 5. And then we have an infinite sequence, which is a sequence with an unlimited number of terms. The example would be 1, 2, 3, 4, 5, ... just keeps going forever to infinity. And that set is actually the set of whole numbers, is an example of an infinite sequence. So today we are talking about sequences in general. Okay, we're going to talk about some specific types of sequences tomorrow and after. But today is just a sequence in general. The pattern here or the order can be anything with what we're talking about today. After today, we're going to get into some specific types, and there'll be some rules that come with that. So let's see. The next thing here is term notation. So you have to know that each number, like this is a term, this is a term, this is a term, this is the first term, the second term, the third term, the fourth term, the fifth term. In this case, the term and the term value are the same number. So this is how we denote it, the notation that we use. The first term in a sequence is called A1. And each subsequent term is denoted as AN, where N is the term number. So where it falls in the sequence. So if we said A4, that would be the 4th term in the sequence. So that's what that is. So let's look at an example. They have an example here of 1, 5, 9, 13, 17, ... So this is an infinite sequence. It's going to keep going. And let's find some of these things. A1 is 1, right here. The first term is 1. A4 is 13. 1, 2, 3, 4. Here's the 4th term. It's 13. A9, we're going to have to find because we only have 1, 2, 3, 4, 5 terms, and we need the 9th term. So we're going to have to keep going, and we're going to have to look at this sequence and decide what the pattern is. How do we get the next term? Well, if you notice, you're going to add 4 each time, and you're going to get the next term. So the next term after 17 is 21, then 25, then 29, 33, 37, 41, and 45. So the 9th term is 1, 2, 3, 4, 5, 6, 7, 8, 9 is 33. And then the last one it asks you for is a 12. That's why I wrote that many. 9, 10, 11, 12, and that equals 45. So for everything that we know right now, to find like the 12th term, you're just going to have to write out the sequence and find what the 12th term is. We're going to have some rules to do that when we have specific types of sequences, but just sequences in general, you're going to have to do that. So since each term value is paired with exactly one term number, a sequence is a function with the following properties. So let's look at this little chart. We've got n, remember, which is the term number, where it falls in the sequence. like 4, A4 is the fourth term. And then we have AN, which is the term value. So what is the fourth term if N was 4? So we're going to fill this in up to 5. 1, 2, 3, 4, 5. And if we have the first term is, and we're going to just look at the sequence that we just used. The first term was 1. The second term was 5. The third term was 9. The fourth term was 13. And the fifth term was 17. So you can see here that the domain, remember, domain is what? When we had X's and Y's, domain was, oh, it switched colors on me, where the X's. So now the domain is going to be the set of term numbers. And the range is going to be the set of term values. Okay, down here. And this is going to be a function, because remember, in a function, you can't, it has to pass that vertical line test. And since they only are one that lines up with it, then this does. So in an infinite set, the domain is the set of all natural numbers, which is 1, 2, 3, 4, 5, up to infinity. Okay, so now we're going to look at an actual formula for a sequence, and we're going to start with a formula called a recursive formula. Okay, a recursive formula is a rule in which one or more previous terms are used to generate the next term. This will make more sense when we look at an example. The example that they're going to talk about here is the Fibonacci sequence. This is a special kind of, or not kind, a special sequence that's named after Fibonacci. And the Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34, ... So let me tell you how we are going to define this sequence with a recursive formula. We're going to first say that A1 equals 1. Actually, I'm going to erase this 0, and we're just going to start it with 1. A1 equals 1. A2 equals 1. And AN equals AN minus 1 plus AN minus 2. So let's look at what that looks like. Okay, in a recursive formula, you have to define at least the first term. This case, we defined the first term and the second term. And we're going to, so now if we wanted to find what the third term was, here's n equals 1, here's n equals 2. If we wanted n equals 3, A3, we would substitute 3's in for these n's, and we would get A3 minus 1 plus A3 minus 2. So what is 3 minus 1? That's A2. And what is 3 minus 2? That's A1. So the third term is the second term plus the first term. And the second term is 1, and the first term is 1. We already had that defined. So that tells us that the third term is 2. And if we wanted to find the fourth term, then we would put 4s in for all these n's, and we would get a 4 minus 1 plus a 4 minus 2. What is 4 minus 1? 3. What's 4 minus 2? 2. So the fourth term is the third term plus the second term. What is the third term? 2. What is the second term? 1. So the fourth term is 3. Okay, so this sequence is the sum of the two terms previous. So to get the third term, we add these two 1s together and we get 2. And then we're going to add these two together and we get 3. And then we're going to add these two together and we get 5. And we add these together, we get 8 and 13 and 21 and so on. And that's what the Fibonacci sequence is. It is the sum of the two terms previous. And this is how you would write, it's kind of messy now because I've circled a lot of things. This is how you would write the recursive rule. You have to define for this one, the first and the second term, and then an. So let's look at some more examples. Example 1, it says, find the first 5 terms of each sequence. So we've got a1 equals 14 and an equals an minus 1 plus 9 for n greater than or equal to 2. Okay, that is just telling you that you can only use this if n is 2 or bigger. You can't use it for 1. That's why we've defined 1 right here. So that's the only reason that this is here. So we're going to look for the first 5 terms. So we want a1, a2, a3, a4, and a5. So a1 is 14, right? They defined that for us. A2, we're going to put 2's in for n here, and we're going to say it equals a 2 minus 1 plus 9. And what is 2 minus 1? 1 plus 9. So a2 equals a1 plus 9. So we're going to take a1, which was 14, and add 9, and we get 23. A3, we're going to put a 3 in for the 1, and we're going to get a2 plus 9. And what is a2? A2 was 23, so it's going to be 23 plus 9, which is 32. A4, we'll put a 4 in, and we'll get a3 plus 9. And what is a3? We just found it. So 32 plus 9 is 41. And then for a5, it's going to be a4 plus 9, and a4 was 41 plus 9, which equals 50. So the first 5 terms of this sequence are 14, 23, 32, 41, and 50. All right, so after a while, you can see what the rule is. The rule is the term right before it plus 9. So you don't have to write all this out. I just was writing it out so that you could see where the numbers come from. If you get it, then you don't have to write it all out. All right, let's look at example number 2. We've got a1 equals 6 and an equals 2 times an minus 1 minus 5 for n greater than or equal to 2. Again, this is just because this rule only works for the second term on up, because the first term has already been defined for you. So let's go ahead and find these. A1 equals 6. They gave us that. A2, we're going to put a 2 in for n, and we're going to get 2 times a 2 minus 1 minus 5, which is 2 times a1 minus 5. So we're going to say that's 2 times 6 minus 5, which gives us 7. All right, it's 2 times the term before it minus 5. That's what the rule is. So A3 is going to be 2 times A3 minus 1 minus 5, which is 2 times A2 minus 5, which is 2 times 7 minus 5, and we get 9. And A4 is 2 times A4 minus 1, and 2 times A3, which is 2 times 9 minus 5, which is 13. And the last one, 2 times A5 minus 1, 2 times A4 minus 5 is 2 times 13 minus 5, which equals 21. So the first 5 terms of this sequence are 6, 7, 9, 13, and 21. Okay, let's look at number 3. See if I can put it here. Number 3 is, actually I'm not, it's a little more complicated. Number 3, we have A1 equals 354, and AN equals AN minus 1 plus 6 over 3 for n greater than or equal to 2. So let's find this. First 5 terms. A1 is 354. A2 is A2 minus 1 plus 6 over 3, which is A1 plus 6 over 3, which is 354 plus 6 over 3, which is 120. A3 is A3 minus 1 plus 6 over 3, which equals A2 plus 6 over 3, which equals 120 plus 6 over 3, which is 42. And A4 is A4 minus 1, which is A3 plus 6 over 3, which is 42 plus 6 over 3, which is 16. And then A5 is this. So you can see the pattern is the term right before it plus 6 divided by 3, and this one is, we're down to a fraction now. All right, so phew, at least we could stop there. We're not going to have any more fractions. So the first 5 terms are 354, 120, 42, 16, and 22 over 3. All right, let's look at the next one. Number 4, we've got A1 equals 3, A2 equals 4, and AN equals AN minus 1 times AN minus 2. And now this has to be for n greater than or equal to 3. We can only use this if n is 3 or bigger, because here's A1 and here's A2. For n equals 1 and n equals 2, it's been defined for us. So A1 equals 3, A2 equals 4, A3 equals A3 minus 1 times A3 minus 2, which is A2 times A1, and A2 is 4, and A1 is 3, and so we get 12. And A4 is going to be A4 minus 1 times A4 minus 2, which is A3 times A2, which is 12 times 4, which is 48. And the last term is A5 minus 1 times A5 minus 2, which is A4 times A3, 48 times 12, which is 576. So that is those are the terms the first 5 terms for that sequence. All right, let's look at the next one. Now, for these first 4 examples, they gave you the rule, you had to write the terms. Now they're going to give you the terms and you have to write the rule. This is hard. I don't know what to tell you, except when we get into the specific type of sequences, there'll be specific rules to use. Right now, when we're just talking about sequences in general, you just have to guess and check and look and think of it as a puzzle and see if you can figure out some kind of rule. So let's look at this one. Because we're using a recursive formula, we're going to say A1 equals 4. And then we're going to look at this and see what in the world we can do. Well, the first thing we could do is look at the difference between these. What's the difference between 4 and 11? That's always one way to start. So that would be a 7. What's the difference between this? That would be a 21. And then the difference between these, 95 minus 32 is 63. And these are 284 minus 95, and that's 189. So does that help us at all? Not too much, because it doesn't really, it's not the same thing. So I'm just going to tell you what the rule is here so that it gives you some ideas of things to look for. Okay, AN is 3 times the term before it minus 1. All right, so see, for this, if we took 4 and multiplied it by 3, we would get 12, and if we subtract 1, we get 11. If we take 11 and we multiply it by 3, we get 33, and if we subtract 1, we get 32. If we get 32 times 3, we get 96, and if we subtract 1, we get 95. So that's the rule for n greater than or equal to 2. It's not really helpful, like I said, it's just kind of a puzzle. Just for this lesson, will you have to do this? Then we're going to have some specific rules, but it also asked you to find the next 3 terms. So for this one would be 851, 2,552, and 7,655, using that same rule. All right, let's look at the very last one of this. Like I said, it's hard. You just have to come up with something and see if it works. So for this one, we're going to say A1 equals 100 and AN equals, let's see, the difference between this is 40, and the difference between these is 20, and the difference between these is 10, and the difference between these is 5. Well, that at least looks like some kind of a pattern. So what's happening to this? It's going in half. I guess that's the pattern over here too. This 7 times 3 is 21. 21 times 3 is 63. 63 times 3 is 189. So that's where this 3 came from. So that's helpful, I guess. So this is going, though, in half. 40 times a half is 20. 20 times a half is 10. 10 times a half is 5. So it's going to be a half times the term right before it. And then what do we have to do? If we take a half of 100, we get 50. So what do we have to do to that 50 to get 60? We have to add 10. Now let's check the next one and see if it works. If we take half of 60, we get 30, and if we add 10, we get 40. If we take half of 40, we get 20, and if we add 10, we get 30. And if we add half of 30, we get 15, and if we add 10, we get 25. So there's our rule. I guess that wasn't too bad. The next terms are 22.5, 21.25, and 20.625. All right, let's move on. This is turning into a long lesson. The next one is an explicit formula. Okay, an explicit formula is, remember the last type with the n minus ones, those were called recursive. These are explicit. This is a rule in which the nth term is defined as a function of n. Previous terms are unnecessary now. Okay, we don't need to know what the previous term is to find the nth term. So in some ways, this is a little easier, I think, and it's more helpful sometimes. So for number 7, it says find the first 5 terms of each sequence. I'm going to do these kind of quickly. We have an equals 7 times n minus 3. So now to list these out, a1 is 7 times 1 minus 3. A2 is 7 times 2 minus 3. A3 is 7 times 3 minus 3. A4 is 7 times 4 minus 3. They ask you for 5. 1, 2, 3, 4, 5, yep. And A5 is 7 times 5 minus 3. All right, we're just substituting n in for this. So these are going to be, the first 5 terms of this sequence are going to be negative 14, negative 7, 0, 7, and 14. Okay, let's look at number 8. We got an equals 1/3 to the n plus 1. So we have a1 equals 1/3 to the 1 plus 1. A2 equals 1/3 to the 2 plus 1. A3 equals 1/3 to the 3 plus 1. A4 equals 1/3 to the 4 plus 1. And A5 equals 1/3 to the 5 plus 1. So you just got to find what these are. This is 1/3 squared, which would be 1/9. This is 1/3 cubed, which would be 1/27. 1/3 to the 4th is 1/81. 1/243, and 1/729. All right, don't you think it's kind of easier? I do, but maybe not. An equals -4 times n squared. So for this one, we would say a1 is -4 times 1 squared. Now notice that the -1 is, or the -4 is not with the squared. The squared only goes with the end, and then you multiply it by -4. So a2 looks like this. A3 looks like this. A4 looks like this. I don't know what happened to my equal sign. So this is going to be 1 times -4. This is going to be 4 times -4. This is going to be 12 times -4. Not 12. I did that wrong. This is going to be 9 times -4. I don't know why I said 12. This is going to be 16 times -4. And this is going to be 25 times -4. Okay, number 10. Remember that when you are doing these notes, if you feel like you got it, you can move on to something else. You do not have to do every example. If we were doing this in school, I probably wouldn't do every example, but I'm going to do them all here because I don't know which ones are most helpful. And you can choose. So here we're putting the n in twice. There's an n multiplied by 2, and then there's an n plus 5. And we get this. Remember your order of operations. You have to do what's in parentheses first. So 5 plus 1 is 6. 6 times 2 is 12. 5 plus 2 is 7. 7 times 4 is 28. Here we got 5, 6, 7, 8 times 6 is 48. And we got 9 times 8, so we got 72. And we have 10 times 10, and we have 100. And number 11, we've got a n equals -2 to the n plus 1. N plus 1? Oh, my computer is that n plus 1 or n minus 1? It's n minus 1. So let me erase that. That makes more sense. So we have a1 is -2 to the 1 minus 1, a2, 2 minus 1, 3 minus 1, 4 minus 1, and 5 minus 1. So 1 minus 1 is 0. Anything to the 0 power is 1. This is -2 to the first power. This is -2 squared. So now it's going to be -2 times -2. So it's going to be positive. -2 cubed, it turns negative, and then it turns positive again. Okay, so it goes back and forth. You see that? Positive, negative, positive, negative, positive. And the last one here, number 12, we've got an equals n minus 4 squared. So we have 1 minus 4 squared, 2 minus 4 squared, 3 minus 4 squared, 4 minus 4 squared, that's an easy one, and 5 minus 1 squared. So we got 1 minus 4 is -3, but -3 squared is 9, 4, 1, 0, and then look, back up to 1 again. Okay, now we have to write the rule. Just like the last time, when they give you the sequence, you have to find the rule. Again, it's kind of guess and check, see what we can do, see what we can come up with. Changed color. All right, so the first thing I'm going to do is see how I get from here to here. -7 minus 2, -9 minus 2, minus 2, minus 2. That's helpful when it's the same thing. So our an, now we don't have to start with a1 because it's not recursive. It's an explicit formula. So our an is going to be -2n. We're gonna, when we have a common thing like that, we're gonna multiply it by this and then see what we have to do. -2 times -7 is -14, and or +14. And what do we have to do to that to get -9? We have to subtract 5. That was wrong. Oh no, to get 7. I did that wrong. Let me explain that again, because that was a bad explanation. We're going to say -2 times 1, because this is the first term. -2 times 1 is -2. And what do we have to do to -2 to get -7? We have to subtract 5. And if we put a 2 in for n, we get -4 minus 5, we get 9. We put a 3 in, we get -9 minus 5, we get 11. So that's where that comes from. And then it says, write the next 3 terms. They would be -17, -19, and -21. Okay, I'm sorry, that was a bad explanation. Let's look at the next one. 3, 6, 11, 18, 27. Let's see what's the difference here. This is a 3. This is a 5. This is 7. And this is a 9. 3, 5, 7, 9. They're not the same, so that's not going to be very helpful. I'm just going to tell you what this one is. AN equals n squared plus 2. Okay, 1 squared is 1 plus 2 is 3. 2 squared, 4 plus 2 is 6. 3 squared, 9 plus 2 is 11. 16 plus 2 and 25 plus 2. Okay, that's what it is right there. Like I told you, sometimes these are just guess and check, see what you can come up with. We're going to have specific rules later. Right now, this isn't going to be a huge part of it. You'll have a couple to try for homework, but if you don't get them, just, it's like a puzzle and see what you can come up with. Okay, let's look at the next one. What can we do here? AN is, I'm going to write, since some of these have 2's on the bottom, I'm going to write all of these numbers as 2. Instead of 2, I could write this as 4 over 2. Then we have 5 over 2. I could write this as 6 over 2, 7 over 2, and this is 8 over 2. That might make it a little easier. We could just put a 2 on the bottom. And what can we do to the top? The difference between all of these numerators, 4, 5, 6, 7, 8, is just 1. So I'm going to take n and add 3, because if n is 1 for this first term, and I need it to be a 4, I need to add 3. And if n is 2 here, and I need a 5, I need to add 3. If n is 3 and I need a 6, I need to add 3, and so on. So this is the rule, and the next terms are 9 halves, 10 halves, which is 5, and 11 halves. And the last one, pretty easy. 1, square root of 2, square root of 3, 2, square root of 5. Again, let's write it. That is that, and that like that, and we can say AN equals the square root of n. And our next terms are square root of 6, square root of 7, and square root of 8, which is 2 times the square root of 2. Okay, those are explicit. Now we're going to talk about series and summation. This is kind of like 2 lessons in one. So this week you're only going to have 3 assignments, so this lesson is a little bit longer. Okay, series is the sum of the terms in a sequence. Okay, the sum of the terms in a sequence. So let's look at some examples. A sum is adding them up. We got a sequence and we got series. So if our sequence is 1, 2, 3, 4, our series is 4 plus 3 is 7, 8, 9, 10. It's 10. If our sequence is 3, 6, 9, 12, ... if we add all those up, we're going to get infinity. And if our sequence is 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... even though we keep adding things, this actually equals 1. And we'll see some examples of that. Okay, so partial sums is the sum of a specified number of terms. So it's a sum of part of the terms, maybe not all of them, and we're going to call that SN. Just like we call AN, we're going to call it SN. So let's look at example 1. And we have 1, 2, 3, 4, 5. and it says find S9. That means you're going to add up the first 9 terms. Well, what do we have here? We have 1, 2, 3, 4. We have the first 5 terms, so we need 6, 7, 8, 9. So we're going to add all those terms up, and you get 45. For number 2, we have 4, 7, 13, 25, 49. And it asks for S4, which means it just wants the first 4 terms, 4 plus 7 plus 13 plus 25, and you get 49. For number 3, we have 1, 4, 9, 16, 25, dot, dot, dot. It asks you for S6, so that's going to be 1 plus 4 plus 9 plus 16 plus 25. That's 1, 2, 3, 4, 5. We need the last term, which in this case is 36, because these are squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. And that's 91. And for the last one, 1, a half, a third, a fourth, a fifth. And it asks you for S3, so that's 1 plus a half plus a third, which equals 11/6. You would have to get a common denominator here, which is 6, and add those up, and you get 11/6. That's number 4. Okay, summation notation. Summation notation is a way to represent a series using the Greek letter sigma. Okay, this is the Greek letter sigma, and we're going to use that to denote the sum. So in this example, they've got a 5 up here, n equals 1 to n. Okay, so let's see what all these things mean. This number right here on top is the last term number. This number right here is the first term number. Where you start, this is where you start, this is where you end, and this is the formula for the sequence. Okay, so now it says find the sum of the above. So we're going to start at n equals 1. So we're going to say 2 times 1. Well, I'm going to write it like this. I'm going to say the sum from n equals 1 to 5 of 2n. I just rewrote that down here. So we're starting with n equals 1. So we're going to say 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. And that's where we're going to stop. Okay, here's where we started with n. So that's where we started. And here's where we end. And we're going to add them all up. And if you do that, you get 2 plus 4 plus 6 plus 8 plus 10 equals 30. So this right here is just a way to write a sum. Okay, we use that all the time in math. It's telling me I have too many whiteboards, so I'm going to have to erase some of them so I can do the next one. So we've got examples. Example number 5. It says find the sum of each series. We've got the sum of n goes from 1 to 12 of n minus 1. So remember this is where we're starting with n, and this is where we're ending. So we're going to say 1 minus 1 plus 2 minus 1 plus 3 minus 1 plus 4 minus 1 plus 5 minus 1 plus, I'm not going to write them all out, all the way to 12 minus 1. So 1 minus 1 is 0. Whoops, not a, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9, plus 10, plus 11 equals 66. Okay, number 6, we've got the sum of n going from 1 to 7 of negative 3n. So that's going to be, this is where we're starting, negative 3 times 1 plus negative 3 times 2 plus negative 3 times 3 plus negative 3 times 4 plus all the way up to negative 3 times 7. Okay, so which equals negative 3 plus negative 6 plus negative 9 plus negative 12 plus negative 15 plus negative 18 plus negative 21, and that equals negative 84. Okay, you don't have to write it all out, but it helps you keep track. Here we've got, they're not using the n, they're using a k now. It doesn't matter what letter they use, it's just like a variable. So here they're using a k, and we're going to start at 1 and go to 4. So we only have 4 terms. So we have 5 times 1 plus 2 plus 5 times 2 plus 2 plus 5 times 3 plus 2 plus 5 times 4 plus 2. And this is 5, 7, 12, 17, and 22, which equals 58. Okay, not too hard, right? Number 8, we've got the sum of a goes from 2 to 9. All right, so this one is a little different. Now we're starting with 2. We're not starting at 1. We're starting at a equals 2. So we're going to have 2 times 2 minus 7 plus 2 times 3 minus 7 plus 2 times 4 minus 7 plus 2 times 5 minus 7 plus 2 times 6 minus 7 plus 2 times 7 minus 7 plus 2 times 8 minus 7 plus 2 times 9 minus 7. So we're still ending at 9, but we're starting at 2 instead of 1. So we're going to have 4 minus 7 is negative 3, 6 minus 7, 8 minus 7, 10 minus 7, 12 minus 7, 14 minus 7, 16 minus 7, and 18 minus 7, and add those all up and we get 32. Okay, is it making sense? Let's find a whiteboard that's easy for me to erase, which is probably none of them, and I'm sure there's an easier way. Actually, I could just do that. All right, and so we have number 9. The sum of y goes from 1 to 5 of y squared plus y. Okay, we're back to starting with 1. So we're going to say 1 squared plus 1, 2 squared plus 2, 3 squared plus 3, 4 squared plus 4, and 5 squared plus 5. So this is going to be 2 plus 6 plus 12 plus 20 plus 30 equals 70. All right, number 10. The sum of c going from 2 to 8 of c cubed over 2. All right, I'm not going to write them all out. We're going to start with 2. 2 cubed is 8 over 2. 3 cubed is 27 over 2. 4 cubed is 64 over 2. 5 cubed is 125 over 2. 6 cubed is 16 over 2. 7 is 343. And 8 is 512 over 2. Okay, I'm writing them all like that. And I'm going to add them all up. And you should get 647.5. Number 11. And we got 3 more. Number 11 is the sum of m goes from 2 to 6 of m squared minus 1. So you've got to notice where you're starting. We're starting at 2. So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. And if you add those all up, it should be 85. Number 12. Oh, okay. I'm going to do number 12 up here. It's a little different now. We've got a 3 out in front. And then the sum of p goes from 4 to 8 of 4 minus p squared. So what in the world are we going to do with that? Well, that's just like a number right out in front of a regular equation. So I can write it like this. And I'm going to just do the sum inside these parentheses. So I'm going to start with p equals 4. So I'm going to say 4 minus 4 squared plus 5 minus 4 squared plus 6 minus 4 squared plus 7 minus 4 squared plus 8 minus 4 squared. So this becomes 0 plus 1 plus 4 I did those all backwards. These should all be backwards. This should be 4 minus 5, 4 minus 6, 4 minus 7, and 4 minus 8. But that doesn't matter because we're squaring everything, that we're going to get the same answer the way I have it written. I'm sorry about that. So this is 4, this is 9, and this is 16. And we're going to add that all up, and we get 3 times 30, which is 90. So basically, when you have something like this out in front, just leave it out in front till you get the very end and then multiply. All right, let's look at number 13. Here's another one like that. Number 13, we have 1/2 times the sum of x goes from 2 to 4 of x squared minus 5. Okay, we're going to leave the 1/2 out in front, and we're going to get 2 squared is 4 minus 5, and 3 squared is 9 minus 5, and 4 squared is 16 minus 5. So that gives us -1 plus 4 plus 11, which is 1/2 times 14, which is 7. And that's our answer. All right, so that is how you do summation. So I told you at the very beginning of the very beginning video that you're only going to have 3 lessons this week, but I think I'm going to divide this one into 2. And so you'll have 4 lessons. You'll have 3 lessons and a quiz.